Hey, Honors Cam, trying to keep these videos short. It's easier to upload them onto YouTube, and you don't have to sit there and watch 15-minute videos. This is the mole part two. In part one, I introduced the fact that a mole of anything would have 6.022 times 10 to the 23rd units of that substance. Some of you, though, might be wondering, why is it such a strange number? Why does it have to be 6.022 times 10 to the 23rd? And this quick little video hopefully will explain why. Okay, folks, this is the best I could do, so I hope this table makes sense. Why is the mole 6.022 times 10 to the 23rd? It's a strange number because it allows us to convert from a unit of mass for very, very small objects like single atoms or even molecules. If you remember, we should be familiar with the term AMU, atomic mass units. If I have one atom of hydrogen, the average atom of hydrogen weighs 1.008 AMUs. That's right from the periodic table. But what the mole does is it allows us to convert from a really small made up unit to a unit that we use every day in the chemistry lab, units that we're familiar with. And of course, those are grams. Notice what I did here. I have three different examples. I have an example of hydrogen, I have an example of carbon, and then, by the way, these are both individual elements. And then I used a molecule, I used a compound, I used water. So let me just take you through this real quick. A single atom of hydrogen has a mass of 1.008 AMUs. That's right from the periodic table. But what if I had an entire mole of water? It's pretty impossible to be working with a single atom of hydrogen in an everyday science lab. We're going to be working with large amounts of particles. That's why the mole is important. If I have a mole of hydrogen, I still have 6.022 times 10 to the 23rd atoms of hydrogen. That's a heck of a lot of atoms. But that in total, notice this, it would weigh 1.008, not AMUs, but grams. And again, you can refer back to this video, so I shouldn't feel guilty for trying to be as quick as I can be here. One atom of carbon, single element carbon, according to your periodic table, weighs 12.01 AMUs. But what if I had a mole of carbon? It would weigh 12.01 grams. Notice, a lot heavier than hydrogen, but whether it's in AMUs or grams, we know that carbon is heavier than hydrogen. But again, a mole of carbon, I would have this number. It's called Avogadro's number. The guy's name was Avogadro. I still have 6.022 times 10 to the 23rd atoms of carbon, but instead of 12.01 AMUs, it would weigh 12.01 grams. Last example, I have water. Notice it's a molecule, it's a compound, H2O. If I add up two hydrogens and one oxygen from the periodic table, I could say that one water molecule weighs 18.02 AMUs. But if I have an entire mole of water, look at this. This number is the same as it was up here. But because it's a compound, water is a compound, I have not 6.022 times 10 to the 23rd atoms, but molecules of H2O. However, it would still, if I added up the masses of two hydrogens and one oxygen from the periodic table, and I put it in grams, that's what 1 mole of water would weigh. I hope that helps for you to do the Poggle that's going to get pushed out. Let me know.